Hello, today we're going to talk about constant rate of change and direct variation. We just discussed rate of change yesterday, so we've talked about how to calculate that rate of change given a graph, a table, or an equation, and direct variation is actually something that we've discussed before as well. It involves the equation y equals kx. So we will look at linear equations like this, y equals kx, and we will write them again and graph them and so on and so forth. In general, I just want to point out what it means to be a constant rate of change. As we discussed last lesson, rates of change for linear equations are constant. So let's just draw a few quick sketches here. These are x and y axes. Again, they can be rough. They don't have to be perfect. As I said before, rates of change for linear equations are constant. So this has a constant rate of change. This has a constant rate of change. But what might something look like if it doesn't have a constant rate of change? Well, that's typically when you get curved lines. So maybe something like this. Okay, so the rate of change, starts off slow and then gets higher and higher and higher and higher. So this is not a constant rate of change. And you'll notice, of course, this is not linear. It's not a straight line. It is a curve. So you will be doing more practice with rates of change. Just remember that when you calculate a rate of change, if you are given units, you need to include those units in your final answer. So just remember units. It helps to know what your numbers mean. Let's revisit direct variation again. We talked about this equation when we were discussing proportions because it represents a proportional relationship. So here we have y equals kx, and as a reminder, k, you can use a lot of different words to represent k, but we talked about it before as representing the unit rate. And I also mentioned at that time that it was also referred to as the constant of proportionality. So these words are back again, okay? And something else we can tag on now is that we could also say that k represents the rate of change. It represents all of these ideas because whatever the number k happens to be, maybe we are looking at the unit rate of a t-shirt. Maybe it's $10 per t-shirt. That is a unit rate. That is also the constant of proportionality, and that is the rate of change, $10 per t-shirt. So it's all the same thing, and it's all wrapped up in k. We have graphed equations of this format before. For example, I may have given you y equals 2x. One way to graph this type of equation is to make a table. You can pick values for x, substitute them into the equation, and solve for y. We'll just stick with a few numbers. When I substitute 0 in for x, I get 0. When I substitute 1 in for x, 1 times 2 is 2, I get 2. When I substitute 2 in for x, I get 4. So these are just some ordered pairs that make this equation true. If you try solving for intercepts here, when you plug in a 0 either for x or for y, you do end up getting 0. So again, just as a note, if you only get 0, 0 as the x and y intercept, you must create a table and find at least one other point so that you can graph your line. Please remember that you should have lines. You shouldn't just have single points at the origin. But it turns out that any equation of this format, y equals kx, will have a point at the origin. So it always goes through the origin or 0, 0. Something else you want to recognize in terms of when to use this equation, you will encounter the words varies directly. So you might see something like that. When we read y equals kx, we say y varies directly. That's why it's called direct variation. as x. And now let's go ahead and practice writing these equations. So again, we should feel pretty good about this since we've done it before, but when we write direct variation equations, there are a couple of steps we can follow. First being find the value of k. And there might be a few different ways you do this. Again, it represents the unit rate. If you find the rate of change, that is k. And depending on the information given, will depend on how you go about solving for that. Okay, but you find k. Once you have k, you need to substitute the value for k into the general equation y equals kx. And again, this does not work for everything. We've written plenty of linear equations that are not in this format, such as y equals 3x plus 4. That's a linear equation, but it does not represent a direct variation situation. It does not go through the origin. So again, be on the lookout for the terms, varies directly before you jump into this. Let's practice with your handout on page 31, number 1, money. So go ahead and get that out. The amount that Jared earns every week varies directly with the number of hours that he works. Suppose that last week he earned $75 for 6 hours of work. Write an equation that could be used to find how much Jared earns per hour. So we want a general equation with that unit rate k. Then we can use that to find out how much Jared would earn if he worked 25 hours. So we've seen the words varies directly. What varies directly as what? Well, it says the amount that Jared earns every week. So that can represent y. Amount of money earned every week varies directly with the number of hours worked. I always recommend defining your variables. You want to know what your x and y represent in order to work with them. Our unit rate k, we want to calculate a unit rate here. That is going to be represented by money per hour, because that's, that makes sense. How much money does he make per hour? And in order to calculate that, we have to use the information given. So we know that Jared makes $75 in 6 hours. So how do we figure out the money per hour? Well, we are familiar with this. We go ahead and we simplify down to 1. Now 75 divided by 6 does not give you a whole number, but that's okay. It gives you a decimal. Why don't you go ahead and hit pause, calculate that, and then unpause when you're ready to see the solution. Okay, so we should get 12.5. So what does this mean again? It means $12.50 per hour. Again, always know what your numbers represent. That way, if you get something that seems really, really off, like if you got a really tiny decimal, 0.125, you might go, wait a second, that doesn't quite make sense here. Okay, let's substitute k back into the equation. So we know k equals, I'm just going to use 12.50 or 12.5 to keep it simplified. I'm going to substitute that into y equals kx, and here's my general equation, which I can now use to calculate the amount of money he earns given any number of hours. How much does he earn in 1 hour? $12.50. How much will he earn in 2 hours? What if he works a 40-hour work week? Again, it makes it much easier now that I have a general equation. So we want to know now how much Jared earns if he works 25 hours. So I'm going to substitute 25 hours in for x. Please hit pause and calculate, and then hit unpause when you're ready to see the solution. Okay, you should have calculated that he makes $312.50. So these were the different pieces we need. Specifically, these two are what I will be looking for. What I'd like you to do now is on page 31, go ahead and do numbers 2 and 3. And hit pause, work through those, and then when you are ready to see the solution, hit unpause. Okay, so I'm assuming you're ready for number 2. The general equation is y equals 2.95x And again, that represents $2.95 per gallon. Remember, you always want to put money in the numerator. You want to know how much money it is for 1 gallon of gas, not what part of a gallon or how many gallons it is for a dollar. So that's the general equation, and then when you solve for 9.5 gallons, you get $28.03. Number 3, here, this one's just a little bit trickier. We have y equals kx, but we can still work with it. You just want to make sure you understand what y and x represent. So y is going to represent the circumference, because that's given first. The circumference of a circle varies directly with the diameter, which is true. So I'm just going to label those. And if you were a little unsure as to how to solve for k, like which number to put where, let's use this equation. They give us a circumference of 47.1 inches when the diameter is 15 inches. So how do you solve for k? How do you get that unit rate? Well, we will divide by 15. So again, if you weren't sure where your numbers go, you can always use the equation to help yourself out if it's not as intuitive as, money per hour or money per gallon. When you divide this, you should have gotten pi, or of course it's rounded here, 3.14, and the general equation will give you y equals 3.14x. This should look very familiar to you, like circumference equals to pi times diameter. I'm just using y and x instead of c and d. And then we can go ahead and substitute our 12 inches in for x and get 37.68 inches. That's all. I will see you in class tomorrow where we will do more practice. Thanks.